Hey, Mr. Bahork here, and today I want to talk about doing two-step equations, solving two-step equations. So, now you should have watched the solving one-step equations videos before you've watched this one. So if you haven't watched that, or if you don't know how to solve one-step equations, you need to know how to do that before you get to this. Okay, so let's move forward. So remember from last time we talked about you had some operations and you had inverse operations. And your operations are like addition, subtracting, multiplication, division. Okay? And each one of those had an inverse. So something that undid the other one. So addition's inverse was subtraction. Subtraction's inverse was addition. Multiplication's inverse was division, and division's inverse was multiplication. Okay, this is going to be helpful to know to help us solve these two-step equations. So here's what we can do. I like to think of the operations as being like, some of them are like more powerful than the other ones. For example, addition and subtraction I consider to be like less powerful. You learn it really early in school, like in kindergarten or before, or in second grade or first grade or whatever. So they're like less powerful. It's like the baby math almost, kind of like that. Or if you want to think of it as like X-Men or something like that, these are like the lesser powerful mutants. And these are more powerful. You learn these later on, like fourth and third grade and stuff like that. Multiplication, division, that is. Or if you want to think of it like my X-Men example, they're like the more powerful mutants, like Magneto or Charles Xavier, or something like that. Okay, so when you tackle an equation, let's go ahead and put up a really basic one. Let's say, make example 1. When we tackle an equation that looks like this, 2x minus 1 equals 7. Okay. When we tackle an equation like this, okay, we're still doing like the same thing to both sides, trying to get x by itself. We're still doing all of that. But we're going to tackle it in a certain order. So what I want to do is I want to take care of the less powerful ones first. It's kind of like, Batman always takes care of the henchmen first, and then he goes after the Joker, the big bad guy. So I see a minus 1, and that's one of the less powerful operations. So I want to take care of him first. So plus 1. I almost wrote a 2 for some reason. Plus 1 on both sides. So let's take care of him first, and then we'll worry about the rest. So minus 1 and a plus 1 cancels out. Now we have 2x equals 7 plus 1, which is 8. Well, what do we do now? Now we're going to take care of the more powerful operation, division, or multiplication, I mean. So we're going to divide both sides by 2, because now it's a one-step equation. So x equals 8 divided by 2 is 4. Just to check to make sure we got that right, we had 2 times x, which we now say is 4, minus 1 equals 7. Okay, well, 2 times 4 is 8 minus 1. 8 minus 1 is 7. So we have the right answer. Okay, now, just to give a little side note here, you can kind of undo stuff in a different order. However, it's not that fun. I'll give you an example. So let's look at the exact same problem. Okay, 2x minus 1 equals 7. Let me rewrite that. 2x minus 1 equals 7. Alright, so I can actually solve for x by dividing by 2 first, but when I divide by 2, I have to divide everything by 2, and now I've got to worry about fractions. Ugh. So those cancel out. I've got x minus a half equals 7 over 2. I want to add 1/2 to both sides. Whoops, kind of sloppy, but pretend that's a 1 over 2. Okay, those cancel out, leaving me with x equals 7 over 2 minus 1, or I'm sorry, plus 1 over 2. That's 8 over 2, which is 4. So we could still get our answer. Notice how I got the answer, but this way has fractions. It's a little bit harder to look at. It's kind of messy. So it's actually more simple to just go ahead and take care of the less powerful operations first, and then go take care of the big powerful operations like multiplication, division. And you can think of it as like Batman. Okay, Batman, he always goes after the henchman first. Okay, and here's Batman over here. He always goes after the henchman first because, well, if he was trying to fight the Joker with all the henchmen still around, okay, well then that'd be kind of tough. Well, that's a really awful Batman. But we're going to go with it. So if he was trying to fight like the Joker with like all those henchmen around and stuff like that, that'd be really tough to defeat him because he's got a bunch of henchmen like hanging on his back. He still might be able to do it because, he's Batman. Like, he still was able to solve this problem here. But it's going to be a lot tougher. So we want to go after the henchmen first, the less powerful guys, and then go after the big baddies. All right, so let's do another example. And let me clear off some space on my screen here and erase that incredibly awful picture of Batman that I just drew. I mean, that was really, really bad. All right, so let's do, we'll go with blue. Okay, so example 2. All right, so let's say we have negative 28 equals 5x plus 4. Okay. So again, I want to take care of the less powerful operations first. So I want to subtract 4 on both sides. Minus 4. Okay. This plus 4 and minus 4, those cancel out. Okay. And negative 28 minus 4, it's the same as saying negative 28 plus negative 4. So that's negative 32 equals 5x. So what should I do now? I want to take care of the more powerful operation, multiplication. So divide both sides by 5. Sweet. So we end up with negative 32 over 5, and I can leave it that way. There's nothing wrong with that. So let's say x equals negative 32 over 5. If you really want to change it to a mixed number, you can. You could say, okay, 5 goes into 32 6 whole times, and remember it's negative. And with 2 out of 5 remaining. So you can go ahead and change to a mixed number if you want to. Okay, I would be perfectly happy with this negative 32 over 5. Oh, whoops, shouldn't have marked that like that. So I would be happy with that negative 32 over 5. Okay, let's do another example. And this one I'm going to make a little bit trickier. So example 3. What if I had x plus 7, but all of that was divided by 2 and equaled, well, negative 10? Well, okay, well, in this case, we've got a little bit of a problem. Okay, I have a plus 7, and normally I'd want to take care of that guy first. Okay, normally I would want to do this one first because that's one of the less powerful operations. However, it's grouped. Okay, remember, in parentheses, exponents, multiplication, etc., PEMDAS, or please excuse my dear Aunt Sally, or whatever you want to call it for order of operations, grouping is more powerful than all of them. Well, remember, when you have a fraction bar, that's grouping. So what we have to do is break the grouping. So now we're going after grouping, okay, so that we can undo this 2 right here. Because I kind of think of this as like, and I know this is really silly, whenever I have like an expression like this in the numerator and there's a number on the bottom, I think of it as like a burning building. Okay, so this is going to be really cheesy. I think of this as like a burning building, and in order to save the people that are on the roof, these people, x plus 7, okay, you have to put out the fire. It's down here, this fire right there. I know that was really cheesy, but I don't know. It works somehow. So in order to put out the fire, let me just rewrite this because of my silliness. X plus 7 over 2 equals negative 10. In order to put out this fire below, we have a divide by 2, so we should multiply both sides by 2 because that's the inverse of dividing. So multiply both sides by 2. Well, a 2 over a 2 cancels out, just like always. Okay, we end up with x plus 7 equals negative 20. And this looks a little bit more solvable. So now all we have to do from here is subtract 7 on both sides. Okay, those cancel out. X equals negative 20 minus 7. That's negative 27. So our answer is negative 27. All right, I'm Mr. Bork, and that was solving two-step equations.